just know what the concern is. I'll be following it like a drill. I don't go left, right. I just keep following whatever we have done yesterday. Guys, is this the intact condition that you have made? Yes or no? Please tell me.
Yes, sir.
Intact. Very good. Anybody who has messed it up, because if you mess up the diagram, it's going to lead you in a wrong direction. Then the next is to shade the lost buoyancy. The entire buoyancy out here would be lost where permeability is 100%, and partially it will also be lost here. Okay, so I have increased whatever I have done. In dB, I have kept the lines closer just for my own reference, not that it is a standard IMO process. No, no, no. In the cargo space, I have marked it, but I have marked them at a distance so that I know. And of course, I've shown the cargo with the dots. This will cause the vessel to sink to a new waterline, W1, L1. Water will rise here, and this will be my D1. Is this the bilge condition diagram everybody has made, guys? Yes or no? Side
Yes,
profile. Very good. Now we'll be at the water plane, and you know what is to be written. I am writing the water plane in bilged condition. At which level? At W1, L1. If I cut the ship at W1, L1, there will be a partial loss of water plane in the way of the bilged compartment. So 100 meters, 20 meters. There will be some cargo surfaces seen here, and there will be a loss here. This L is 30 meters, that is 20 meters. Is this the water plane, guys? Yes or no?
yes, sir.
Anybody who's got any doubts, please, instead of just focusing on taking down from the computer, what you need to do is you need to, if there is the issue, tell me what the issue was. I'll ask you why that was set so in your mind, and then we'll be able to sort it out. Now, guys, when it comes to sinkage, I look at the upper diagram. There are two distinct portions. One is DB where 100% is lost, and other is cargo space in which partially it is lost. So what is the height of the cargo space up to the water line in the intact condition? This is B minus H, right? So the lost buoyancy in the way of the DB is LBH. This is what you have lost in the DB. Then how much have you lost in the cargo space? It is L into B, but the height of the cargo here where buoyancy is lost is this into permeability because it has some cargo. Divided by intact water plane, I have my eye on the lower diagram. It is LB minus LBP. Guys, if you have written it correctly, then it's only a matter of putting values, and it should give you answer of 1.227. If anybody has not got it, or if anybody has any doubts, please let me know. Plus. Everybody is good with it? Yes or no? How much will be D minus H? D minus H in this case will be 4 meters, guys, obviously. That does not need any brainers. Guys, all 40 guys, students in the class are okay with the sinkage? Anybody has any doubts? Let me know. Then, I do not, I ask myself, is KB D1 by 2? Anybody would like to answer? D1 will be now 7.227 meters, 6 plus 1.227. Will KB be D1 by 2, guys? Yes or no?
No, sir.
No, sir.
No. Why? Because if you
It's not
visualize
same.
if you visualize the water plane in way of the DB, then you will have 100% loss in that small LB section. When you visualize anything above the tank top, above the DB, there will be partial loss because of the cargo. So you're absolutely right. It has to be calculated by moments. Now, KB in the bilged condition will be vertical movement of the underwater volume. So I'm writing, if anybody does not understand, again you have to tell me what is the issue. This is the vertical movement of the underwater volume up to W1 L1. From here, I need to knock out, either you can put a box bracket or you can make some minus minus both. There are two distinct volumes which are under the water and are not contributing to buoyancy. It's 100% volume of the DB tank. How much is that volume? LBH. What is the lever of this volume? H by 2. Whatever the value be, I'm not interested in 2, half or 1 and all that. I'm doing in the notational form. Another is the volume above it. Now guys, here you have to be little careful. Let me change the marker. I'm doing it just for sake of clarification. This is the volume above the DB which has gone underwater and is not and partially not contributing to buoyancy. How much will be this volume? It will be the length of the compartment, breadth of the compartment, and this height. This height will be D1 minus H. And this would be the volume which is not contributing to buoyancy if it was empty. But it has permeability, so this will reduce in the same proportion. This is the volume in the cargo space which is under the water but not contributing to buoyancy. Where will be its geometric center? Geometric center would be here. What will be the lever? Lever will be half. This is D1 minus H by 2 plus H. I'm just messing up the diagram. You don't have to do it on the diagram, guys. I'm sure you'll agree. The lever is D1 minus H by 2 plus H. And this is the vertical movement of volume of buoyancy post bilging divided by volume of buoyancy LBD. And when you put these values, it will give you a KB of 3.770 meters. Anybody has any questions and anybody was struggling here, let me know. Is it clear to everybody, class? If you write like this and in the next step you put the values and then write the answer, you're good. 3.770. In the next step, put the values of capital L, small l, B, and all that. What will be D1 minus H by 2, guys? It will be 7.227 minus 2. That means 5.227 divided by 2. That will be D1 minus H by 2. And then whatever you get after dividing by 2, you will add H to that. Is that clear, beta? Is this expression clear to everybody? Kindly confirm. Class, are you good with it?
Yes, yes. Good with it.
Pakka? Okay, very good. If you make the diagrams clearly and if you follow the notational method, you will not get stuck. Don't fight with the values from the word go. Put the values once you put in the notational form. Then we come to the BM part. Of course, the center of flotation will be here. There are three intact water planes. This is only explanation, one, two, and something out here. But instead of adding all three, we can, the fore and aft axis will be the center line because the water plane is symmetrical. So BMP will be equal to ICL of what? Of the intact water plane divided by volume of displacement. This will be equal to ICL of the whole water plane minus ICL of the lost water plane. You can write like this, divided by volume of displacement. If you're comfortable, you can put the values, otherwise you can write in the notational form. What will it be? It will be L B cube by 12, that is the first term, minus, what is the second term? If it was empty, it is LB cube by 12, Since there is permeability multiplied by P divided by volume of displacement LBD. And when you put these values, you'll automatically get answer of 4.889 meters. Am I right, class? Yes or no?
Yes, sir.
And you add the two, subtract the given kg, and you have the answer 1.155. I told you yesterday, those of you who have been able to do this question, that means whatever we discussed yesterday has been well understood, it has been well taken, and you are ready to apply that. Guys, anybody has any questions, please let me know. फटाफट बेटा अगर कोई डाउट है तो बोलो, then I'll go to the next question. Okay. No doubts? Okay, good. Now, guys, yesterday we did one question, one I gave you as homework, and then we did maybe that GM question also you would have done. Now, there the permeability was given to you, beta. Now, in MMD exams, sometimes the permeability may not be directly provided its value. Instead of that, what they may give you is the density or relative density of cargo, not of the water, I'm talking of the cargo. And secondly, they have to give you the stowage factor of the cargo. Now, if this information is given in the question and permeability is not given, then first you will have to carry out one more step before you start solving the Bilging. You'll have to calculate permeability. Okay. Now, guys, is there a difference in the value of density and RD? No. If density is expressed in tons per cubic meter, then the numerical value of RD and density are same. So whether it is RD which is given or density which is given in tons per cubic meter, the numerical value will not change. Guys, what is the unit of density? Unit of density is tons per meter cube, weight per unit volume. Guys, if I make, so what does it say? It is basically trying to say how many tons will 1 cubic meter of the cargo actually weigh. Am I correct, beta? If you say density of a cargo is, let us say, 1.2 tons per cubic meter, what does it mean? That if you take 1 cubic meter of the cargo, its weight will be 1.2 tons. Am I right, class? Yes or no?
Yes, sir.
Correct? Okay.
Correct.
And on what thing does the density depends? It is a cargo specific value. It depends on the nature of cargo. Iron ore is a high density. If you take 1 cubic meter, it will weigh much more than if you take cotton 1 cubic meter, which will weigh one much lesser. So it is related to the nature of cargo. Now, if I make it reciprocal of density, you don't have to learn it. It is called as specific volume. Anyway, if you physics mein, this is called as specific volume. That means you make reciprocal of density. If you make reciprocal of density, what will be the units of the specific volume, guys? What will be the units? If you make it 1 by
Meter
density,
cube by
what?
ton.
Meter
Meter
cube
cube
by,
by ton.
by tons. That means whatever is the value here, the so-called specific volume, is the cubic meter occupied by 1 ton of cargo. When we are talking of density, we are saying how much does 1 cubic meter weigh? Now we are saying how much space will 1 ton of cargo actually occupy? So 1 ton per ton means 1 ton. How many cubic meters will it occupy? So that means in our example, it will become 1 by 1.2. Can you divide and give me how much it comes up to 3, 4 decimal places, guys? Point
8333.
8333 cubic meters per ton. What does it mean, beta? It means if I take 1 ton of this cargo, it will actually occupy 0.8333 cubic meters of space in the wherever I keep, whether I keep it in my home, I keep it on my ship, I keep it in my chat, or I keep it on my floor. Every ton of this cargo is going to occupy this, and this is based on the nature of the cargo. This is being driven by the nature of cargo. Obviously, if you take 1 ton of iron ore, it will occupy much less volume. If you take 1 ton of cotton, it will occupy much more volume. Now, guys, what are the units of stowage factor, beta?
Metric cube per ton.
Metric cube by ton. What does it mean? It means when the cargo is actually placed in the ship, let us say stowage factor of the same cargo is 2 cubic meters per ton. That means when this cargo is actually placed on the ship, every ton of this cargo ends up eating or occupying 2 cubic meter of space. Does the cargo expand? No. Cargo will continue occupying 0.8333 cubic meter only. What happens to the remaining space? The remaining space is the broken storage. Why? Because of the shape of the packaging of the cargo, shape of the cargo hold, because of the frames, because of stiffeners, because of the flare, so many factors. Because of that curvature of the ship, the space gets wasted. So on the ship, stowage factor represents how many cubic meter of the cargo space will be occupied by 1 ton of cargo when it is placed on the ship. So actually the cargo is occupying only 0.8333, but on the ship, if I how much cargo will I load? I'll take the full volume divided by 2 and I'll say this is the amount of cargo I can load. So guys, what is the difference between stowage factor and 1 by density? This is your broken stowage. Yes or no? Am I right, beta? Correct?
Correct.
Okay. So now you had 2 cubic meters of space taken on the ship by 1 ton of cargo. Of this 2 ton, only 0.8333 is physically occupied by cargo. How much is the broken stowage? Then broken stowage is 766
1.1667.
1.1667 cubic meters per ton. That means, guys, out of 2 tons, cargo occupies only 0.8333. Remaining is empty. It's gone waste. But in case the bilging takes place, water will not allow that to remain vacant. So this 1.667 cubic meters is available for the water to occupy in case of bilging. Am I right, guys? Yes or no? Correct?
Yes. Correct.
So out of total of 2 cubic meters, how much is available for water to occupy? 1.667 cubic meters. If the space was 1 cubic meter, how much would be then available for water? Divided by 2. And if it is 100, then how much? 100. When anything is out of 100, that becomes percentage. So this becomes permeability in percentage. Yes or no, beta? Have you understood?
Yes, sir.
And this one.
You don't have to explain all this. You just have to apply this formula in the exam. Permeability is equal to stowage factor minus 1 upon density or relative density divided by stowage factor into 100. And so much percentage will be the permeability. Now, sometimes they may not, now they may give you broken stowage and stowage factor if it does not give you density. So what does permeability becomes? It becomes
Broken
broken
storage by storage.
stowage upon, yeah. So don't get confused by these small variations if somebody brings, right, guys? Correct, beta? So you will be able to calculate permeability, and once you calculate permeability, you can put to use for further questions. You know how to use the permeability once you know it. Is that clear, guys? So in case the permeability is not given, but you are given additional information regarding the cargo, then first you will have to calculate permeability, and whatever you calculate will have to be put to further use. Can I now close this issue? Can I assume that you know it, guys? Yes or no?
Yes.
I am clearing the screen and I'll show you there will be a small question which will come, which you can calculate and check the permeability. I'm clearing the screen, guys. If anybody wants to take any screenshot or anything, please take it. Okay. Whatever is coming here, I have already explained. Every term I have explained to you. Density, relative density, specific volume, stowage factor, and broken stowage. And then we said calculation of permeability. Permeability is equal to stowage factor minus 1 upon density divided by stowage factor into 100. Permeability is in percentage, or broken stowage by stowage factor into 100, depending on how the information is provided to you. And all this we have discussed. And can you please calculate the permeability for this? Answer is already given there. Can you please calculate the permeability and just practice once?
Done, sir.
Okay, it's 37.5% is the permeability, and then this can be put to. So it is like a question giving you that permeability is 37.5%. Then you know how to put the given permeability or this calculated permeability to further use. I hope if it comes, you'll not mess it up, guys. Can I draw some confidence from it? Then you'll be able to take care of it.
Yes, sir.
Okay. Now, guys, we go to a very typical scenario. Yesterday, let me clear this screen and use it here for explanation, and then I'll go next. I'm not talking about this now anymore. This is already done. Guys, yesterday we said sinkage is equal to lost buoyancy upon intact water plane. Okay. I did not highlight, I said I made statements. I don't know how many of you noted that statement. When we were drawing the diagram, if some of you can recall, I said, is the water plane between WL and W1L1 identical in the bilged condition? Yes or no? Do you remember this? I am talking of a water plane area between WL and W. I'm not talking from keel. If this was WL, here was the cargo which was bilged. Then what did I say? That, okay, this was the lost buoyancy, water rises here, this is W1, L1. And then I made this statement a few times. I don't know how many of you noted it. I said, is the water plane, when I was explaining why it is lost buoyancy by intact water plane, that was the time also I emphasized upon it, that the water plane area between, in the bilged condition, between the two water lines is identical. Yes or no, beta? Correct?
Yes.
So this formula was good because of this reason. What was the reason? That between WL and W1L1, the water plane was identical. Therefore, this became like this, because if you remember, I made a notebook like this. Correct, beta? Yesterday when I was explaining,
Yes.
I made a notebook like this. And I said all pages of the notebook are identical. And then you are cutting out something. So that means each water plane was identical. Correct, beta? Between WL and W1L1. Am I right?
Yes, sir.
Yes, sir.
Yeah. Today, we'll discuss a situation in which you may not be sure as to where the water line lies. So let's go to that question and we'll talk in context of the question directly. A blank file, okay. Okay, this was for my explanation, then I'll go to the next one. Let me take it here. Now, when can there be a slight issue? The issue can be like this. If you have a ship and you have a compartment, wherever it may be, and you have a water line in the intact condition. Now, in yesterday's questions, there was no watertight flat from waterline WL to the deck. There was nothing in between. Am I right, guys? There was nothing in between here. If there was a DB, it was somewhere below the waterline, correct? Am I right?
Yes, sir.
But now suppose there is a watertight flat instead of here. or it can be in addition to it. Suppose there is a watertight flat here. At what edge? Let us say draft is 6 meters or whatever it is. And let us say there is a watertight flat at a height of 6.5 meters. Now, the watertight flat is above the intact water line and reasonably close to it. Now, if this compartment gets bilged, you will lose some buoyancy. How much will the vessel sink? The vessel will sink as much as required to regain the lost buoyancy. Now, looking at this question, I cannot say whether my vessel will sink by zero point 0.5 meters, because if it sinks by zero point 0.5 meters, then my W1L1 will come in line with the watertight flat. Or will my vessel sink less than zero point 0.5 meters? That means then my water line is below the watertight flat. Or does it sink more than zero point 0.5 meters? Then in that case, my water line W1L1 goes above the watertight flat. Am I right, Vita? Yes or no?
Yes, sir.
So guys, if the water line lies below the watertight flat, something like this here, below the watertight flat, then there will be loss of water plane at the final water line. But if the water line goes here, then it becomes completely intact, like the DB. Yes or no? So the water plane area will change based on whether the final water line W1L1 is below the watertight flat or in line with the watertight flat or above the watertight flat. If it is in line with the watertight flat or above the watertight flat, the water plane will become intact. If it is below the watertight flat, then there will be loss of water plane. Have you understood the dilemma, guys? Yes or no?
Yes.
So if you have such a situation, what situation? If you have a situation where there is a watertight flat given just above the water line, intact water line. If you have a watertight flat given just above the intact water line and close to it, and you cannot figure out where your final water line is, then tell yourself you have to be careful in calculation of D1. You'll have to be careful in calculation of D1. So is the problem statement clear before we talk of the solution, guys? Have you understood which situation are we talking about? What is the problem statement here? Yes or no?
Yes, sir.
Solution cannot be understood unless the problem is appreciated, guys. So let's not rush to the solution. First, let's appreciate that yes, there will be a concern. So here I'll not be able to use the same formula which I used until now, that sinkage is equal to lost buoyancy upon intact water plane, because I don't know how much is the intact water plane. I'll get to know the intact water plane only when I get to know where the water line is. So how do we address such situations? Let's take it through a question. Okay. A box-shaped vessel, 100-meter long, 20-meter wide, kg 7.5. Can you guys make a intact condition diagram? Can you make the diagram in the intact condition for the ship? Side elevation in the intact condition. So I'm not still talking about bilging. Can you please make the diagram so that when I make, you can compare the diagram you should be able to make, the side profile. I'll make the diagram and then you tell me if you made the same thing or not, or did you miss out anything, and if so, and if you need any clarification, let me. Length 100 meters, breadth 20 meters, floating at a draft of 6 meters. You have midship compartment, length 30 meters, breadth 20 meters. And now there is a watertight flat at a height of 6.5. So WL is representing 6 meters. So obviously the watertight flat shall be somewhere here. This is your H of 6.5 meters. It has cargo. It has cargo with permeability. It has cargo of permeability zero point 0.6. Right? Is this the diagram you guys made, or you made something else? Is this the diagram you made for the intact condition, guys?
Yes.
Anybody who made something else and wants clarification? Now, guys, in this diagram only, please shade the lost buoyancy. You already know how to shade the lost buoyancy. Please shade the lost buoyancy. I'm sure you would have shaded up to 6 meters. Am I right, guys? Yes or no? Correct?
Yes, sir.
If it's bilged, can you please calculate the lost buoyancy? Will be equal to L E E into P. How many cubic meters? Can you give me the answer, guys? Calculating on your calculator. I don't want to fill up the sheet, unnecessarily.
So
3600.
2160.
2160 cubic meters. Anybody has any questions on any step? Please interject then and there. How much buoyancy do I have to regain? I have to regain 2160 cubic meters. Sorry. Guys, now so what will we do? First, we'll find out how much buoyancy the vessel will regain if the water line is in line with the flat. That means if the draft becomes equal to H. Now from WL to H, I'm sure you'll agree with me that there will be a loss of water plane. So what am I drawing? Water plane up to watertight flat you can write, or you can write up to draft of 6.5 meters. Up to. So I'm sure you'll agree the water plane up to that there will be a partial loss of water plane because of cargo. Because of the cargo water being there, you have cargo here and there will be a loss of water plane. Does everybody agree with this, what I have said, or you have any questions to ask? Tell me, guys. Does everybody agree? Is this the watertight flat up to 6.5 meters, guys? Yes or no?
Anji, sir.
Yes, sir.
So now what we'll do is the volume, the buoyancy regained, we'll carry out a check here now. Buoyancy regained if vessel sinks up to watertight flat. How can I get the buoyancy regained if vessel sinks up to watertight flat? You have this intact water plane of this, what is drawn here. I'm sure everybody would agree it will be equal to, the buoyancy regained will be equal to intact water plane into the sinkage. And how much will be the sinkage? Half a meter. So I'm sure, do you agree with me? L into B, the whole water plane, minus LBP, the lost water plane, multiplied by sinkage of 0.5 meters. Will this give me the buoyancy regained in case the vessel sinks up to watertight flat? First, agree with the second. This is statement one. This is statement two. Do you agree with the second statement, guys? Yes or no? Ali, Keshav, do you agree with this? Yes or no? Akshay
Still,
Yadav, Akshay Yadav, all
Yes.
clear?
Yes.
yes,
Guys,
sir.
I'm only calling some names who have asked doubts in the past. Does not mean that others are left out. If you have any doubts, I'm just prompting. So So I'm giving you time to accept. How much does it come, guys, if you put the values?
820.
820.
Eight. Now, guys, suppose this value would have come 3000 cubic meters. Suppose. What does that represent? If this value had come 3000, what would that represent? Where is the water line then?
Below the this
Below the
Below
water
the
line.
watertight flat, sir,
Very
6.5.
good. Suppose had it come exactly 2160, what would it represent? Or what would it
Same at
mean?
draft.
in
6.5
line with the
meters.
water
That
type.
means D1 is 6.5, correct? It's in line with the watertight flat, correct, beta? Yes or no? So this value will tell you whether the watertight flat, whether W1L1 is below the flat, in line with the flat, or above the flat. In this case, what is it telling you? Is it above the flat or below the flat?
Above the flat.
Above the flat. So 820 cubic meters is regained up to H. So therefore, buoyancy to be regained above the watertight flat, because now the water plane will change. Above the watertight flat will be equal to 2160 minus 820. How much does it come, guys? 1340 cubic meters. Am I right?
Yes, sir.
That means you are still to regain another 1340 cubic meters. What is the water plane area above the watertight flat? Now I'm drawing it here. Water plane area above the watertight flat. It will be fully intact, guys. There'll be no loss of whether you see, you'll see this, and there will be no loss of water plane. Do you agree with me, or do you have any reservations on it, guys? There'll be no loss of water plane, correct? Am I right? Does everybody agree?
Hmm.
Yes.
Yes.
Yes, sir.
With this water plane, I need to sink adequately to regain 1340 cubic meters. So therefore, sinkage beyond, या तो लिख दो watertight flat or 6.5 meters. That means after 6.5 meters, how much is the more sinkage to take place? How much is the buoyancy to regain? 1340 divided by the intact water plane thereafter. Intact water plane is 100 into 20. And how many meters is the additional sinkage beyond 6.5, guys?
0.67.
0.670. Therefore, your final draft after Bilging D1 will be 6.5. You sink to regain 820, plus you sink another 0.670. It will be 7.170. Am I right, Peter? Correct?
Yes, sir.
So now once you calculate this, now you will mark your W1L1. Until now, you could not have marked your W1L1. So you see in this case, W1L1 will be marked now, not in the initial diagram only, initial stage. So now I can mark the final water line W1L1, which is after bilging, in which this draft D1 is 7.170 meters. Now this question has become like a DB of 6.5 meters height. Yes or no, beta? Am I right? Now this question has become like a DB of 6.5 meters height. Correct, beta? Am I right? Will the water rise above the watertight flat to W1L1?
No,
No,
sir.
no, sir.
So what will be the water plane area at W1L1? This will be the water plane area at W1L1. Yes or no? Am I right? This will be the water plane area at W1L1. Am I right, guys?
Right,
Yes
sir.
or no?
Yes, sir.
Yes, yes, yes.
Yes, very good. Will the KB be D1 by 2? Yes or no? First tell me that.
No, sir.
No,
No,
sir.
sir.
All of you to calculate KB, I will not write anything unless you ask me a question. Answer of the KB is given there. Please calculate KB in the bilge condition and see if it is matching 3.650. If it is not matching, let me know. And I will not write any step unless somebody says that he is not understood. You know how to calculate the KB now, guys. Please calculate.
हाँ जी सर आ गया.
आ गया? जिनका आ गया वो BMB कैलकुलेट करो बेटा. Draw the, choose the appropriate water plane at W1 L1. Mark the center of flotation. Draw the 4.5 axis. Calculate BM, and once you get BM, you can calculate the GM.
Yes, sir.
Very good, very good, very good. Let's wait for everybody to complete. Let's give another minute or so. So if you understood yesterday's content well, now it is minor tweaking here and there and just little bit of care which needs to be exercised. There's nothing new. And believe me, if you learn well what you did yesterday and you learn well what you are doing today, then tomorrow when you do the trim related questions, you will have no problems whatsoever.
आ गया सर.
The concept, yeah, okay, good. Guys, anybody has any questions on KB, BM and getting the GM? Or if somebody is still calculating and wants me to wait, please let me know. Otherwise, I'm shifting the slide. I'm shifting the slide unless you have a question. Akshay Yadav, calculate ho gaya beta. Did you get the GM?
So KB I calculated.
तो आगे भी तो करो ना. तो फिर बोल क्यों नहीं रहे? मैं कह रहा हूँ मैं स्लाइड शिफ्ट कर रहा हूँ, तुम बोल नहीं रहे हो. And then you will keep lagging behind. Keshav, how far have you reached?
Sir, done, sir. हो गया.
Okay, very good.
GM आ गया.
Okay, very good. Ali, you also got the GM?
Yes, sir, already.
Very good. अक्षय फटाफट करके बताओ मुझे. अक्षय यादव, not the other Akshay.
Done, sir.
Done. Is that Akshay Yadav who said done? Is it?
Yes, sir.
Okay, then I can go to the next question, guys. Now, guys, now you see in textbooks also and the way people teach, what have they done? They have made an exercise on GM of the bilging of midship compartment, in which they are asking for GM. And in the process, what do they end up doing? They end up giving a wrong message to the students that GM will be required to be calculated only if the midship compartment is bilged. Well, guys, it's not so. Why? Any of my compartments can be bilged. Why should it be always midships? It can be forward, it can be aft, it can be midships, it can be to the port, it can be to the starboard. Guys, tell me one thing. When you load cargo, do you always load midships? You load cargo forward, aft, port, starboard. Whenever you load cargo, let us say MV in ship question. Suppose she is floating at some draft which is given to you, and now she loads 2000 tons in number 1 hold at some given kg. Are you required to find GM, yes or no? When you have loaded in the there will be change of trim also, na? And you have loaded in the forward compartment. Will there be a change in the GM of the ship, yes or no? Tell me. If I load in number 1.
Yes.
Tell me, guys. If I load some cargo in number 1 compartment, will the GM of the ship change, yes or no?
Yes, will change.
Will change,
Yes, sir,
no?
will change.
Correct. So what has happened is in bilging, the textbooks have also probably somewhere missed out on it, because they have titled the exercise as bilging of midship compartment, and then people started following them and not what. So the guys, If I have to ask you the GM, I don't have to necessarily build a midship compartment. I can build the compartment anywhere and still ask you to calculate the GM. And that is what this particular slide is talking about. Calculation of the GM transfers if a non-midship compartment is pilched. Guys, there's no difference. It's only question of being aware of it. Guys, the ship stability has three components. Ship stability has three components. One is the static stability,
Well, longitudinal or
corrected,
transverse.
longitudinal and transverse. Okay. The measure of static stability is GM or GZ. Longitudinal is
Trim.
trim and transverse
List.
is list. This is what your three things are there. Now, all the three components of stability are important, but you can't calculate them in one way, in one formula, put everything and you'll give a comprehensive output. No, they will be calculated separately. Now, when we calculate static stability, we do not care for the longitudinal and transverse stability. That means when I'm calculating static stability, I'm calculating GM or GZ for a ship. I'll assume the ship to be on even keel, upright condition. When I have to calculate the longitudinal stability, I don't care about the static stability and I don't care about the transverse stability. Even if the ship is listed, I'll assume it to be upright. Likewise, when you calculate list, when you say tan theta is equal to W into D upon W into GM, does it take into talk anything about the trim, guys? Does this formula talk about trim? No. So, guys, whichever component you are calculating, you just focus on that component. Don't get distracted that okay, there will be trim, there will be no trim, because you will be disregarding the other two components when you are calculating any one of them. Have you understood what I said, guys? Yes or no? Clear, better? Okay. So in a question in exams, if somebody builds a compartment forward or aft and says GM, then you should not go into a spin, sir. The question is wrong. GM is asked, midship compartment should be built. No, the question is very much right and valid. Can I clear the screen, guys, if you have understood what I'm saying and get to the question then? Here is the question. There was no need to clear the screen. It was on the next thing. Okay. Okay, guys. It has two parts. First is part A. A box-shaped vessel, 190 meters by 25 meters, is at even keel draft of 8 meters. KG 6.823 has a compartment at its forward end. The compartment is 15-meter long, divided into port, center, and starboard compartments. Port and starboard compartments are 6 meters wide each, and center is 13 meters wide. Calculate the GM of the vessel. Let's only talk of part A right now. In the next slide, we'll talk of part B. Only the center compartment is pitched. Guys, using what we learned yesterday, I will draw the intact condition of the vessel. Now, in the intact condition, if there was a trim, you will draw the horizontal water line at the mean draft or height draft. Okay. So even if there was no, in this case it is even keel, that's okay. But even if it was not even keeled, you will still draw it like this only. Length 190 meters, breadth 25 meters, floating at an even keel draft of 8 meters. It has a compartment at its forward end. When you see it from the side, you will not be able to figure out whether it is divided or not. So you see it from here. Is there any permeability, guys? No? Okay. Now, this is the water line in the intact condition. Now we are doing only the center compartment is bilged. What is the length of the compartment? Small L is given as 15 meters.
13.
And what is small b? It is the breadth of the center compartment, which is 13 meters wide. Have you understood why I have written only 13 meters? Because in the side, our compartment getting bilged is only 13 meters wide. Next, we'll shade the lost buoyancy. I'm sure in the side elevation, you will be able to show it like this only. Guys, I know she will trim by head. I know she will trim by head, but we'll draw because as I said, we are talking of static stability. We don't care for whether she is trimmed or she is even keel. Will the water rise between WL and W1L1? Please confirm yes or no.
Yes.
Yes,
Will the
sir.
water rise? Yes. So I mark that here. See, guys, I'm just following it religiously. I'm not playing around with any shortcuts. Once you get the sinkage, you will get D1. Guys, would you like to try making the water plane area at W1L1? Try making it using the common sense and what we have done. Water plane area at W1L1 in bilged condition. Can you please make it? Here, there is no watertight flat, so obviously sinkage will be lost buoyancy upon intact water plane. Remember your water plane, your tank is divided into three. I'm sounding you, so don't make mistakes. You will see this bulkhead here. You will see one tank on the Stepova side, another on the other side. This will be 6 meters, and this is 13 meters. Length is 15 meters. Capital length is 190. Capital B is 25. And will there be a loss of water plane? Yes. Which will be the loss of the water plane? This will be the loss of water plane. Am I right, guys? Have I done it correctly? Please tell me. Class, do you agree with the diagram?
Yes, yes, sir.
Okay. Can you please calculate the sinkage now? Answer is already there, guys. Write in the notational form. Write in the notational form, put the values and tell me. If anybody does not get sinkage as 0.342, let me know, then I'll write in the notational form. You already know how to calculate sinkage now, guys. Is that good? 0.342, everybody's got? Please confirm.
Yes, sir.
Okay, very good. Anybody who's not getting sinkage of 0.342? Okay. So can I presume that everybody's got sinkage, guys, and sinkage needs no explanation? 0.342. I'm just writing 0.342 then here. What will be D1 then? It will be 8.342 meters. It goes on the diagram. Okay. Guys, look at the side profile and tell me, will KB be D1 by 2? Yes or no?
Sir.
Is KB going to be D1 by 2? Yes or no, class?
Yes, sir.
So then write that statement here, which I told you yesterday, and then calculate KB D1 by 2 and confirm that you've got it as 4.171. Write the statement so that you don't miss out writing it. You have to give the reason if you're cutting short, otherwise do by moments. Please write the statement, practice it. Otherwise, you will struggle in the exams what to write. Is the KB part okay, beta?
Yes, sir.
Now, mark the center of flotation wherever you think approximately it would be, and then draw a fore and aft line and let me know if it is the center line again or is it not the center line. Guys, is the axis for BMT center line, yes or no? Please tell me.
Yes, sir.
Center of flotation will be slightly aft of midships because you've lost in the forward part. It will be somewhere here, but it will be on the center line for sure. Why? Because when I draw the center line, it is dividing the water plane into exactly mirror image on each of one side on the other. Now, based on what you know, can you please calculate the BM? So KB, you already have 4.171. I'm not doing anything. You are doing bulk of it. Calculate BM 6.438. Is center line standard access, yes or no, for whole area, lost area? Just see that. Try to calculate. If you're not able to, then let me know. And then you can get the GM answer and match it. If you're not able to match it, let me know.
हाँ जी सर मैच कर
Match हो गया? Okay, let's give some time for others to do. So this question does not require any special effort. It's only that you should not be disoriented because somebody shifts the space, builds compartment and asks you to calculate GMT. So you should not be asking yourself questions whether I can do it, how do I do it. Once you've done one question, then you know how to handle the issue. Okay. Anybody who's still doing and wants me to wait on this slide till you finish, please let me know. Unmute and give me a shout. You want me to wait?
Oh, 30 seconds, sir. I'm doing.
Okay, no problem. Once you're done, let me know. Once you have completed, just unmute and confirm. No problem.
Sir, BM coming wrong, sir. 1.6821 something, sir. I did.
What have you done? What have you done? Can you?
Sir, I center line whole. I did 100 into length.
Is the length 100 meters?
Yes, sir. online. That's right.
See the breadth also. It should not happen that you are using next to make the breadth wrong. Go with take the dimensions from the question, please. Guys, don't you think Bilging is straightforward, simple? कोई इसमें ऐसा तो नहीं है. I don't think it's something to bother about, right? If you just follow the steps religiously, you'll have no issues. And if you have understood moment of inertia and other things, then you will be able to apply them here. That's not going to cause any discomfort.
Yes, sir. Answer done.
Okay.
6.483.
Okay, guys.
Okay.
Now let's go to part B of this question. Can you please make the diagram, guys? Side profile in the intake condition first. Then shade the lost buoyancy. Then mark W1, L1. Then see whether the water will rise or not. Take appropriate steps. Complete the side profile, including the bilged water line. Complete it, and then I'll do. Please complete the side profile. Guys, is this the diagram you made? Breadth is 6 meters into 2 compartments, right? Correct, beta? For part B, is this the diagram you made, class? For the side profile, please confirm.
Yes,
आई
sir.
लोगो यही बनाइए या कुछ और बना दिया आपने को?
यही बनाया सर.
Okay, then make the water plane area at W1, L1 in the bilged condition. I'll also take a lag. I'll lag behind intentionally. Please draw the water plane area at W1, L1 in which condition? In the bilged condition. Please draw it here. Guys, is this the water plane area in the bilge condition at W1 L1 or you made something else?
Yes, sir. Yeah, yeah.
Okay. Anybody who has doubts in the diagram, if you make the diagram wrong, you are going to be getting the wrong values for sure, unless there is some by chance you are able to get some correct values, but otherwise you're on a wrong path for sure. Is everybody in agreement with the diagrams, guys? Bolo bhai. Otherwise, I'll keep moving and you'll some of you will keep lagging behind. Are you okay with the diagram?
Yes, sir.
Agree, sir.
Okay. Can you please calculate sinkage now and confirm it's 0.315 beta?
Yes, sir.
Yeah, okay, very good. I'll write it in the notational form just for the sake of good order, otherwise it's not required. One particular compartment, any one side, it will be L E into lost buoyancy is LB D into 2. This is the lost buoyancy divided by intact water plane, capital L into capital B minus small l into small b into 2. And you put these values, you should be getting 3.315 meters. Does everybody agree, beta? Yes or no?
Yes, sir.
Yeah, good. Again, the question is KB 1 by 2 of D1? Yes or no? So D1 will be equal to
Yes, sir.
8.315. So please again write the statement and close out the KB part. KB final will be 4.158 meters, but please write whatever is to be written so that it becomes part of your system and habit. I'm not writing intentionally because I want you to recall and write. Okay. Those who have closed out the KB, can you please mark center of flotation and draw a fore and aft axis through it and confirm whether it is center line or not of the ship.
It is the center line, sir.
It is the center line of the ship. Okay. Now, here I would like to draw your attention. We can calculate the, so first, KB everybody is done, guys? Yes or no? KB everybody is done?
Yes, sir. Yes, sir.
Okay. So center of flotation will be on the center line slightly aft of midship, doesn't matter how much aft. And the fore and aft axis will be obviously the center line of the vessel. Now guys, what is my BMT? It is in this case ICL of the intact water plane upon B. Guys, why did we make it ICL of the whole minus ICL of the lost? Because it was making things easier for us. Am I right? Yes or no? Because I was telling you repeatedly, you could have
Thank you, sir.
added the moment of inertia also. Yes or no? Correct?
Yes, sir. Correct.
Now, in
Yes,
this
sir.
question, I'm asking a question. Is center line a standard axis for the whole water plane? Yes or no?
Yes, sir. For whole water
Yes, sir.
plane.
Yes, sir.
And is center line a standard axis for the lost water plane? Yes or no?
No, sir.
So if you continue whole minus lost, which is okay, that is correct. I'll do that also finally, no problem. If that is so, then you'll have to use theorem of parallel axis for the lost water plane. Correct, beta? You'll have to bring it from to center line.
Correct.
Am I right?
Correct, sir.
Correct, sir.
Because we
Correct,
have
sir.
spent 4 sessions on moment of inertia. But in this question, since there is no cargo in the compartment, we can also get by adding the moment of inertia of these two areas, which I'm now marking in different colors. You see, my intact area here comprises of, it is only convenience, guys. I'm not changing the style of working. You can, if you want to continue with the old one, you can continue. This is one intact area of which center line is a standard axis. And this is another intact area whose center line is a standard axis. Am I right, guys? A1 and A2 are the only intact areas in this question.
Yes.
Yes or no? What are the dimensions of A1? 190 minus 15. This is 175 is this length and breadth is 25. So instead of, just to cut short, it's only for convenience, guys. Can I make it like this? I1 about CL or ICL1 plus ICL2. Am I right, guys? The way we were doing earlier upon volume of displacement. Can I do this? Yes or no?
Yes,
Correct,
yes.
guys? That will make things easier for me because center line is a standard axis for both of them. A1 as well as A2. So I don't have to use theorem of parallel axis. So it is only to avoid the use of theorem of parallel axis. But don't worry, I'm going to give you a question for homework where there will be no escape. Okay. So in this case, I can cut short if I want by ICL of area 1 will be length 175 is the length of the area A1 into 25 cube B cube upon 12, that is this part, plus I2, the length is 15, breadth is 13 cube by 12, divided by volume of displacement 190 into 25 into 8. And can I get the BM straight away? 6.069 through a shorter route? Yes or no, beta?
Yes, sir.
Okay. I'll do it by theorem of parallel axis also. Don't worry. I'll do it because next question which I'm going to give you for homework, that will have permeability, and then there will be no choice because there will be intact areas in the side tanks
नहीं
also for
सर,
the
थ्योरम ऑफ पैरेलल एक्सिस से भी सेम आ रहा है.
same aayega beta. It will come the same. It will come the same. I'll just do for the benefit of the class. So why we made it A1 plus A2 is because of convenience, not to that parallel axis cannot be deployed. It can be deployed, guys. Has everybody understood this? Yes or no? Now the same BM I'll do by the same method that we were doing, guys, earlier. Now BM is equal to ICL of the intact water plane upon volume of displacement, so that if you're not comfortable with a switch, you can just continue following it. It will be ICL of the whole water plane minus ICL of the lost water plane upon V. This will be equal to ICL of the whole water plane minus 2 into
into ICL of
ICL of one compartment divided by volume of displacement. Now, what do? I'll change to blue pointer so that it is here. Now, ICL is not a standard axis for the lost water plane. So what do? Through the geometric center of this, I draw a parallel axis. Maybe I can call it as XX, no problem. What is the perpendicular distance between these two? 3 meters here and another 6.5 here. D here, or you can say y is equal to 9.5. Why I'm not using D? Because D is the draft here. You can call it y or whatever. So now this will be equal to, if I write in the notational form, guys, ICL of the whole water plane will be LB cube by 12. That is not an issue. Minus 2 into IXX of one compartment plus area of lost one compartment into y square divided by volume of displacement. Am I right, guys? If I apply theorem of parallel axis, now I'll put
yes,
the
sir,
values. Now it will be 190 into 25 cube by 12 minus, please remember, it's plus here, So if you multiply, either you solve the bracket first, that will be easier. So use the calculator carefully, guys. Divided by Ixx of one compartment will be 15 into 6 cube. 15 into 6 cube by 12 plus area of one is 15 into 690 into y square is 9.5 square divided by 190 into 25 into 8. And when you solve this, it will give you the same answer back, guys. Is that clear, beta? Has everybody understood? It's a theorem of parallel axis that we have mastered in 4 sessions of moment of inertia and its application that is being applied here.
6 divided by 3 is 2.
So I have done it both ways. Those of you who want to save time can follow the previous one. But guys, sometimes there may not be escape, because in the next question that I'm giving you for homework, I'm putting permeability here. So now you will have A1 as intact, A2 as intact, you'll have some part intact here, you'll have some part intact here. So in such a case, it will be ICL of the whole minus ICL of the lost, which is the best way if there is permeability. So I give you, guys, I'm going to the next question unless somebody has anything to seek clarification about. Next question will, again, like I gave you one question for homework, which is to test how much have you understood. This question, I don't know whether it is in the sheet that I've shared with you or not. I'm not sure. Is it there in the sheet? Just see, guys. Are both the answers there? Let me go check. If it is there, then you don't have to worry. Otherwise, you can take a screenshot of it. Let me see if it is there or not. 15, 9, no, it is not there. It is not there. Can you take the screenshot of this question, beta, please? It has all the answers, subparts also, syncage, A, B. This, what, okay, I'll move this side. One second. I'll move this side. One second. Now take it. It's the same question. I have only brought in permeability of 65%. This is answer B. I'll also show you answer A, guys. I'll also show you answer A. Okay, both the answers are summed up here. You can take this one. Both the answers are summed up here. Okay, A and B are both here. Would you like to solve them better on your own?
Yes, sir.
Because this will give you opportunity to apply yourself, and if there is any doubt, I can always see where you are getting stuck, and that will probably help you in ensuring that you can avoid some doubts. Okay, guys, now I come to basically last of the questions. I hope everybody has taken this. This is your homework for today. Okay, now we come to the last of it. I can give you 5 minutes break if you want. It's 10:54. Take a 6 minutes break. 11 o'clock we discuss this. Okay, beta? 11 o'clock, right?
Okay, sir.
Okay. Shall we start, guys?
Yes, sir.
Yes, sir.
Okay, fine. Now, guys, when we started with permeability, we discussed certain inherent assumptions, like the cargo not being lost, cargo remaining secure to the ship. And under those assumptions, we did the permeability questions where the solid cargo was being carried. But if the compartment which gets bilged has liquid in it, whether it is water, oil, or whatever it may be, the tank content cannot remain inside the tank. And obviously, the tank content will be lost to sea. Okay. And what will happen? The seawater will fill up the bilged compartment. So, how do we find the GM in such cases? If the compartment which is bilged was carrying some liquid cargo or liquid in it, whatever it may be. Okay. So, guys, one thing is for sure that if a car compartment is carrying liquid, gets bilged, what will be the final stage? Final stage will be all the tank content will be lost to sea, and the tank's volume will be space will be occupied by the seawater. Am I right, guys? Yes or no? Correct?
Yes, sir.
Excuse me,
Now,
sir.
yeah, tell me.
What if the building has happened somewhere on the bottom and the density of the cargo is very less
Doesn't
compared
doesn't doesn't matter. Have you not heard of oil spilling from DB tanks, better? If the DB tanks have bunker tanks get bilged, have you not heard of bilging oil spill taking place? Does it take place? Yes or no?
Yes, sir. But does it completely go out? Like what I mean to
Yeah,
say,
I
the
so
liquid level.
what was the word I used? I used the what will be the final stage. In how much duration you reach the final stage, that will depend on various factors, right?
Okay.
Eventually, the tank content would be lost to sea. It will be replaced by water. Whether it happens in 10 minutes or it happens in 10 days or it happens in 2 months. This duration will depend on many factors. For example, number one, what is the head of the seawater outside and what is the head of the liquid inside? Okay, so it will first depend on that. Second, it will depend on the size of the damage. Third, it will depend upon the weather conditions. If the weather is rough, vessel is rolling pitching. If you have gone on deck when the vessel is rolling pitching, and if you go past the air pipes of your tanks, what do you get to hear, guys? You get to hear the tank breathing heavily, air gushing out and gushing in as the liquid moves from side to side. Yes or no, beta? Have you heard that? In rough weather, if you
Yes,
go
sir.
past the vents
Yes,
of
yes.
tanks carrying liquid, you hear that air going in and out heavily, the tanks breathing heavily. So here the liquid could not escape because the hull is intact. So the air was escaping and coming in and coming out. Just imagine if there was a damage down below, then would this oil not escape better? This will escape. And as I told you, in how much time will it completely escape? That is, I've already told you, that can be a variable time depending on multiple factors. But yes, what will eventually happen is oil would be lost. Whether oil or anything liquid, it can be fresh water, it can be seawater also inside there. No issue. Whatever was in the tank before bilging would be replaced, lost to sea, and it will be replaced by seawater. That is the final thing that will definitely happen. How in how much time it happens? I told you it can be dependent on various factors. Does that answer your question, Samuel? Now,
Yes, sir.
okay. So, guys, let's say I take a DB here. Let's say I take a DB here. Okay, let me do it in the question only. Why do otherwise? Okay, here is a box-shaped vessel. Let me do this, explain with this question. Length 100 meters, breadth 20 meters, kg 7.5, and floating at an even keel draft of 6 meters. It has a midship compartment. Again, the compartment can be anywhere. Now the focus is on this concept, so we don't complicate by the DB, which is 2 meters high. H. It is full of fuel oil. RD 0.95. This is the initial condition, correct, guys? Yes or no? Am I right? Okay, beta.
Yes, sir.
Now, what is the displacement of the vessel here in the initial condition? What is the displacement of the vessel? Obviously, the density of the sea water is not given. That by default we taken as sea water. The displacement will be length, law of flotation, length into breadth into draft into density of seawater. How much does it come, guys? Can you calculate?
12300.
12300. What is the kg of the vessel in this condition? It's given in the question as 7.5 meters. How much is the oil in the concerned tank? That will be the volume of the oil multiplied by the density. That means 30 into 20 into 2 into 0.95. How many tons does it come, guys?
1140.
1140. Guys, what will be the kg of the fuel oil? Look at the diagram and tell me what will be the kg of the
1
fuel
meter.
oil? 1 meter. 1 meter. You all agree with this? It's simple basic law of flotation and the geometry of the compartment concerned relate. Guys, in such questions, I said this oil will be eventually lost. So let's imagine the vessel is intact and I intentionally discharge this oil. This is an assumption. Okay. The vessel is still intact and I knock out this oil. And this imaginary condition we'll call as intermediate condition. We'll call this imaginary condition as intermediate condition. What is this intermediate condition that we have named here? It is an imaginary condition in which, with the vessel remaining intact, the compartment which is getting bilged is assumed to have been intentionally emptied. That means the liquid has been discharged. So what will happen? When you discharge this 1140 tons of liquid oil from this DB, the displacement of the vessel will change. Am I right? Correct, beta? The displacement in the intermediate condition will become less by 1140. So it is 12,300 minus 1140. 11160 tons. Will this change the draft of the ship? Yes. If the ship is intact and you're discharging weight, it will change the draft in the intermediate condition. How much will it be? 11160 divided by the density of the seawater and divided by length and breadth. And how much draft do you get, Peter?
5.443.
5.443, 444. Just check again, but that's all I'm asking. 3 or 4? Round off.
3.
3 or 4. 5.443. 5.444. 4 आ रहा है. Okay. 5.544. Okay, fine. No problem. It's okay. What will also change will be the kg of the vessel. Am I right, Peter? Because you have discharged some weight. What will be the final kg? Initial vertical moment. Initial vertical moment it is 12,300 into initial kg of 7.5 minus the vertical moment of the weight discharged, that is 1140 into 1 divided by the final displacement of 11160. How much is the kg in the intermediate condition, guys? 8.164. 164 meters. Now, I will draw the diagram for the intermediate condition here. What is the length of the vessel? 100 meters. What is the breadth of the vessel? 20 meters. There is a dB here of length 30 meters, breadth 20 meters, height 2 meters, which is now empty. But now the draft of the vessel is reduced to 5.444. Am I right, guys? Now the draft is reduced to 5.444, correct? And the kg of the vessel has altered to 8.164 meters. Does everybody agree, guys, what I have drawn here? Yes or no?
Yes, sir.
Guys, now in the initial condition diagram and the intermediate condition diagram, some parts I'll draw in red. Not draw, I'll mark in red, sorry. What have I done? I've left the dB out. And I'm doing the same thing here. Are the two conditions, intermediate and initial, in the red part of the ship exactly same, or have we changed anything there also?
Same, sir.
Same. Where is the difference? Difference is only the dB. Correct, guys? Am I right? In these
Yes,
two
sir.
conditions, what is the difference? The differentiating part is only the dB. In one case, the dB is full. In the other case, dB is empty. And what is it doing then? It has caused a change in draft. It has caused a change in kg. Am I right, guys? But the red part of the ship in both the cases is exactly identical. So whatever is the difference in their stability in the two conditions, which conditions? Initial condition and the intermediate condition. Whatever is the difference in their stability in the two conditions, the difference is because of what? It is purely because of the dB concerned. Yes or no? Am I right, beta?
Yes, sir.
The difference in the stability of initial and intermediate condition is what is the differentiating factor? Whatever is the difference you owe to dB. Because in one case dB is full, in the other case dB is empty. Does everybody agree or any questions are on that beta? Clear? Now, if in both the cases now, if I bilge the dB, so what will happen? In the initial condition, this oil will be lost and this thing will be completely filled with seawater. This buoyancy will be completely lost because it is occupied by seawater, which is communicating with the sea. Am I right, beta? Oil will be lost if
Yes.
the bilging takes place, and this dB will be filled by seawater from outside, and this will become the lost buoyancy. Am I right, guys? Yes or no?
Yes, sir.
Correct. And if the dB in the intermediate condition is also bilged, then what will happen? This will be the lost buoyancy again and filled with seawater. Correct, beta? Correct.
Correct, sir.
Yes, sir.
Now, when both the cases the dB is filled by seawater because of the bilging, now are both conditions same now, or is there any difference now left after bilging? After
Sir.
bilging, is the condition same now? So whatever is the stability of this one after bilging, same will be the stability of the initial condition after bilging. Am I right, guys? Correct?
Yes,
Yes
sir.
or no? So what do? And you know how to calculate the GM when the empty compartment is bilged. So you can bilge the intermediate condition and get the GM. Same will be the GM for the initial condition bilging. Yes or no, beta? Am I right? Have you understood? So now, there you did not know how to deal with the liquid, but now when you are bilging in the intermediate condition, you are bilging an empty dB. Yes or no, beta? Am I right?
Yes, sir.
And
Yes,
you
sir.
know how to bilge empty dB, and you know how to calculate the GM. So whatever will be the GM of the intermediate condition after bilging, first agree with me on this statement. The GM of the vessel in the intermediate condition after bilging will be same as the GM of the vessel in the initial condition after bilging. Do you agree with me? Yes or no?
Yes, sir.
So then you know how to proceed with these questions. Now, I will be. Do I have it on the next page also? No, I don't have. Okay, I don't have. Okay, so let me clear this screen. I'll do this question again so that we can, because it was more for explanation here. Let me do it now with a slightly smaller diagram, and we'll try and complete on this screen. Otherwise, we can carry it on the next page. No problem. Guys, see. First, I make the ship in the initial condition. Here is the vessel. 30-meter length is 30 meters, okay. And this is full of fuel oil. Kg is 7.5 meters. Okay. What do? I calculate the initial displacement. 100 into 20 into 6 into 1.025. We got 12,300 tons. We know the initial kg, 7.5 meters. We can calculate the small w, the weight of the tank content, that is 30 into 20 into 2 into 0.95. Was it 1160 or 1140, guys?
1140.
Yes, sir.
1140 tons. Kg of the fuel oil is 2 by 2 equal to 1 mole. Now we come to intermediate condition. Displacement in the intermediate condition. And what is intermediate condition? In which the vessel is still intact and you have intentionally emptied the compartment. Is 12,300 minus 1140. That is 11160 tons. We get the draft in the intermediate condition, not final draft in the intermediate condition. 1160 by 1.025 divided by 100 and 20, 5.444 meters. We get the kg in the intermediate condition, and we get it as initial vertical moment 12,300 into 7.5 minus 1140 into 1 divided by 11160. Was it 8.164? Can you please confirm once again? Am I right when I'm recalling it?
Yes, sir.
8.164.
Okay. Now I make the diagram for the vessel in the intact condition for the intermediate condition. Now I'll forget the initial condition completely. Length 100 meters, breadth 20 meters. Oh, sorry, breadth 20 meters. My mistake. You have this compartment here. Now the compartment is empty. Length 30 meters, breadth 20 meters, height 2 meters. But now the vessel is not floating at 6 meters. Now the vessel is floating at 5.444. You said something, better say again.
Sir, answer again.
Okay, very good. And the kg of the vessel in this condition is 8.164. Now I shade the lost buoyancy if the dB is bilging. This is the lost buoyancy. This will cause the vessel to sink to a new level, W1L. Will the water rise between WL and W1L1? The guys, tell me quickly, will the water rise there? Yes or no?
Yes, sir.
Water will rise between WL and W1L1.
No, sir. नहीं नहीं water will not. New D1 act.
Okay, so then the water plane at W1L1 in bilge condition will be fully intact. It is intact with length 100 meters, breadth 20 meters. Am I right, guys? Yes or no?
Yes, sir.
Okay, okay. Now, we just start overlooking. We ignore the initial diagram. If you don't cancel it, it remains part of your working. But now your focus shifts on what you have bilged. So sinkage will be equal to lost buoyancy, which is LBH upon intact water plane L into B. How much is the, put the values, how much sinkage do you get, guys?
0.6.
Everybody is good with 0.6, please confirm. And everybody is good with sinkage. So D1 will be how much? D1 will be how much, beta? D1 will be equal to draft before bilging, which is now 5.444 plus 0.6.
6.044.
6.044 meters. It goes on the diagram here. Guys, look at the diagram for intermediate bilged condition. Will KB be D1 by 2? Yes or no?
No, sir.
No.
KB final? No. So it will be by moments. What will it be? Vertical moment of underwater volume up to D1. That means 100 into 20
20
into
into
6.044
into
into
6.044 divided by 2
0.644 by 2
minus
minus the
8
vertical
into
moment
20
of the, yes, lost buoyancy not contributing to buoyancy, 30 into 20 into 2 into 2 by 2 divided by volume of displacement. Be careful here. What was the displacement of the ship or volume of displacement before bilging of the DB? The draft is 5.444. Please be careful. This is area of mistake. In hurry, you should not write 6 meters here. Correct, beta? Am I right? You are
Right, sir.
doing these calculations for this condition. So everything is pertaining to this condition now. How much is the KB you get, guys?
3.244.
3.244 meters. Now we go to the water plane at W1L1. We have fully intact. This is the center line. So DMT will be ICL of the intact water plane. The full water plane is intact upon volume of displacement. It will be LB cube 100 into 20 cube by 12 divided by volume of displacement. Volume of displacement, either you can take by displacement or you can do length into breadth into height. वो आपकी मर्जी है बेटा. 100 into 20 into 5.444. Again, be careful about the draft. How much does the BM come, beta?
6.122, sir.
6.122 meters. Once you have KB and BM, you are good, but please remember, KG in the intermediate condition is 8.164. It is no more 7.5. So the GM after bilging will be KB, which you calculated as 3.244 plus BM 6.122 minus kg 8.164. Don't miss out, don't make mistake. And it should come, whatever is the answer, 1.204 meters. Whatever is the GM for the intermediate condition after bilging, same will be the GM for the question that we started with, because we have already discussed the reason for it. So is it now understood how to deal with a compartment if it is carrying liquid better?
Yes, sir.
Okay. Okay, yesterday, whose question was that? That was Keshav. Keshav, when you said what happens if the vessel is trimmed. So in the previous question where we built the forward compartment, that our question gets answered, calculating GM. Keshav, that was your question
Yes,
yesterday,
sir.
right? Okay. So there, after
Right,
putting
sir.
the vessel was trimmed, right? And so that was also addressed. I
Yes,
remember
yes.
that question you raising yesterday. So guys, is it clear
Thank
how to deal with the vessel bilging a ship if the compartment bilged is carrying liquid? It could have been seawater, it could have been fresh water, it could have been any oil. Doesn't matter. You have to treat it as the tank content. That's all you have to do. Is that clear, beta?
you.
Can I just ask you to do the same question if this DB was full of seawater before bilging? Can you do it again and find out if the DB was carrying this thing? I don't. It just came to my mind what you're saying. So if instead of this oil of RD 0.95, if it is carrying seawater of same density as outside 1.025, will you be able to solve this question today, bit also?
Then there is no
Yes,
change.
sir.
There will be change. There will be no change in the draft, but
KG may have
GM
different value.
intermediate KG will change. Samuel,
Okay, yes, sir, yes, sir.
that's why it stuck to me while I was talking to you. I said, let me give you with seawater, right? Good, I gave this question. So
Yes, yes, yes.
okay. Let me just copy this question on the next slide so that for the next batch I don't miss out. Let me copy this question on the next slide because this is how I also keep updating my material based on something so I'll calculate the GM later. This answer will not be correct. Fuel is full of seawater. बस इतना करके छोड़ दो इसको. No, this is the question I'm asking you to do. Is it now okay, beta? So let me remove the answer completely. Answer I'll write later. No. This is the question I'm asking you to do. Is that clear, beta?
Yes, sir.
So please do this question. So you have two questions for homework today. One is where you have the forward compartment with permeability of 65%. And this is another question. And rest, whatever you want to practice from somewhere, anywhere, whatever source, that's your choice. And if you're getting stuck in any of those questions, you can bring the question to the class. So from my side, guys, this completes. I don't call it as midship compartment. What I prefer to call it is calculation of GM in bilged condition is complete. Calculation of GM in bilged condition is complete. Tomorrow, we'll start accounting for trim so that we can get the drafts forward and aft after bilging. And believe me, if you can apply what you have learned over yesterday and today, you will be able to run through with that component in no time. Okay, stability doesn't, only the reference axis change, formulae need to be recalled, but the process of solving the question will not change. So you need to be, and guys, they get connected, moment of inertia, it is now being used here. Okay, so things do remain connected somewhere or the other. So you need to be just carrying it along. And my suggestion would be don't waste time on too many books. If you can understand, you understood what is done in the class, then best is to attack the past papers. That is the best way to deal with. Okay, guys, I'm done for the day. I think I can release you half an hour early today. If you want, you can do these questions on your own today. And if you have any doubts, let me know tomorrow. Is that clear? Clear, beta?
Yes,
Can
sir.
you
Okay, sir.
please
Yes, sir.
try
Okay.
that?
Yes, sir.
Yes, sir.
Yeah.
I think
Okay.
the
Okay.
question which you
Can you
solved
send
now.
trial running, sir?
Yeah, I'll send right away. Somebody else was speaking something. Tell me who was
Yes, sir.
speaking.
Yes, sir. Sahil, sir. The
Sahil.
question which you solved now for the RD fuel,
Uh,
you said ki for the initial condition when the fuel oil tank was filled with the fuel oil and the
uh,
final condition when it was built, the GM will be same because there is no change in the water plane area.
Did I say this? क्लास में था या नहीं था इससे पहले जो मैंने दो डायग्राम बना के when I cleared the board and I explained why they'll be same. Were you not in the
yes
class?
sir, yes sir, yes sir.
तो फिर
आपने बोला
फिर ये तो ये किसने ये water plane area suddenly कहाँ से आ गया? Did I say that for both conditions it is same because the water plane area is same? Why did I make this
no, no, sir,
statement?
water level. Sorry sir, water level.
Well, did I say so? Did I say so? Did I say so?
No
तुम
sir,
अपनी तरफ से कुछ भी ऐड कर देते हो क्या? मैंने ऐसा कहा था क्या? अब वो तो डायग्राम मैंने मिटा दी. Now you are asking me to redo it again, redo
no,
all
no,
over.
sir. No sir.
Then did I use these words that you are using? I never
No, sir,
use these words that you're saying. Sometimes you're saying because the water plane is same. Sometimes you're saying water level is same. I never use these words to say that both will have the same GM because of this reason.
You said for the same, we have to calculate the KB. That case you said
I'm not talking of KB calculation. Now, see, now you have gone into calculations. That is your basic problem. You keep shifting the goalpost every statement. You never, first your doubt was कि दोनों का सेम क्यों होगा, ये डाउट थी ना तुम्हारी.
Yes sir. Then I
तो वो मैंने अभी समझाया नहीं था जब दो डायग्राम बना के before I started solving the question. Did I not explain?
Yes sir. Then I
तो फिर क्या डाउट है तेरे को? उस टाइम डाउट क्यों नहीं पूछा तुमने?
नहीं वो then I calculated for that condition sir.
अरे यार कैलकुलेशन में छोड़ दो. तो now you are saying कि इंटरमीडिएट कंडीशन का बिल्स GM इनिशियल कंडीशन के बिल्स GM के बराबर क्यों होगा? That is your question, correct?
Yes sir. The initial
and that is what I had explained. What did I explain to start with?
ये एक्सप्लेनेशन समझ आया सर, बट मैं उसका कैलकुलेशन किया जो फाइनल GM 1.204 आया और जब इनिशियल का कैलकुलेट किया मैंने वो थोड़ा डिफरेंट आया सर.
तो इनिशियल का क्यों करोगे? तो यार समथिंग इज रॉन्ग विद यू और व्हाट साइड?
But you said sir it will be same, that's why. But my mind
is so if it was to be same, then we are fools that we are going through intermediate route and wasting our time. Are we fools who are wasting our time, Sahil, that we are going through intermediate route if they were to be same? Sahil, you are either not in the class or you are not listening in the class. There is something seriously wrong with you. I can tell you this now with certainty. You are not getting what I'm telling you. You are not understanding what I've said. And now तुम पूछोगे जब क्लास बंद होने की बारी आएगी, then you'll go to the start line again. And बेटा इतना patience मेरे अंदर नहीं है because I put my heart and soul when